Now we're going to take a look at a function in standard form, and we're going to pick out all the pieces of information, the little details about the graph, like the x-y-intercepts, the vertex, the axis of symmetry, the point symmetric to the y-intercept, domain and range, the graph, all those different things. And we're going to address those in standard form, okay, or from a function in standard form. So we'll start out. Probably the easiest thing to find when you have a function in standard form is the y-intercept, right? The y-intercept, remember, in standard form is always 0, c, ABC, where c is the constant. And that's because when you plug the 0 in, all of the x terms become 0. They disappear, and all you have left is the c value. So in our case, the y-intercept is 0, 4. Okay. Probably next, we could look at the x-intercepts. To find the x-intercepts, we of course set the function equal to 0. So we have 0 equals negative 3x squared plus 6x plus 4. Now in a quadratic equation, of course there are three main ways to solve those. You could use the quadratic formula, completing the square, or factoring. I'm going to go ahead and use the quadratic formula on this one. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the quadratic formula will give us the solutions to a standard form quadratic equation. When I plug those numbers in, okay, negative 6 plus or minus the square root of, well, b squared is 6 squared is 36, minus 4ac, well, minus 4 times a, the negative 3, that's a double negative, makes a positive 12, times 4 again, that's the c, is 48. So 4ac is 48, and then you've got your double negative there to make the plus. Then on the bottom we have 2a. Well, 2 times negative 3 is negative 6. Okay. And so from here we simplify. 36 and 48 should give us 84. That's a negative 6 on the bottom. Right, that's 84, yeah. And then when I simplify this root, the square root of 84, remember that roots can be separated between factors. And so I would simplify that. I'll take it off to the side here so you can see my work. The square root of 84 is the same as the square root of 4 times 21, 4 being our perfect square factor. When I split this root up, root 4, root 21, square root of 4 is 2. The square root of 21 has no perfect square factor. So 2 square root of 21 is our simplified form there. So I'd have negative 6 plus or minus 2 root 21 all over negative 6. Okay, now this is still a bit messy. What I might do here is split the fraction up between the two terms and write this as negative 6 over negative 6 plus or minus 2 root 21 over negative 6. Okay, so I've just split the negative 6 between the two terms on top. That's the distributive property. And then I divide out, or simplify. Negative 6 divided by negative 6 is 1. Plus or minus. Now when you apply a negative to a positive, you get a negative, and when you apply a negative to a negative, you get a positive. So you still have 1 plus and 1 minus. So I'll just leave it as a plus minus, and I've incorporated the negative, so I don't really need that anymore. And I get, and then I can reduce the 2 and the 6 to make a 3 on the bottom. That becomes root 21 over 3. Okay, so this would be a simplified form. Now, it's not easy to plot this on a graph without knowing the decimal approximation. So I'm going to go to my calculator and punch that in. I want both a value from the plus and a value from the minus. Okay, so from the plus first, I punch in 1 plus square root 21 over 3. And that gives me approximately 2.53. I'll just round that to the nearest hundredth. That'll be good enough for a point on the graph. And then I do the same thing with a minus. So 1 minus root 21 over 3 is approximately negative 0.53. Okay, the decimal portions are actually the same there. All right. Okay, so let's get rid of my work up here so I have some more space. So that tells me my X-intercepts then, and actually I'm going to erase a little bit more of this as well. Allow myself to fill in some more work here. So my X-intercepts are approximately 2.53 comma 0 and negative 0.53 comma 0. Okay, after having solved with the quadratic formula. Okay. Now, the next thing I would probably choose to do is the axis of symmetry. We know that the axis of symmetry is found using the formula x equals negative b over 2a, right? So now I just plug in the b and the a, so that'd be a negative 6, the b is 6, and the 2a, well, 2a is also negative 6, and so what we end up with there is simply a 1. All right, so that's my axis of symmetry, just simply x equals 1. Okay, and it does need to be an equation because vertical lines are defined by an equation with an x in them. Okay, next is the vertex. Remember, the vertex is found by using this same formula. So the h value is the 1. Remember, vertex is h and k from the vertex form. So the x coordinate, or the h, is 1. The k, or the y coordinate, is what you get when you plug that 1 back into the function, right? It's f of negative b over 2a. So I take the 1, plug it into the function, we'll go up there. That's negative 3 times 1 squared plus 6 times 1 plus 4. Well, if I evaluate that, 1 squared is 1 times negative 3 is negative 3. 6 times 1 is 6. Negative 3 and 6 is 3. And 4 makes 7. So my vertex then is 1 comma 7. Okay. All right. So that gives us quite a bit of information so far. I'm still missing a couple things. The point symmetric to the Y-intercept. Okay. Remember, the point symmetric to the Y-intercept is always the combination of 2h comma c. Remember, it's double the value over to the axis of symmetry, and then it has the height of the Y-intercept. And so when I look at the 2h, h is 1, so that means 2h is 2. And the c value, we found that earlier, is 4. So 2 comma 4 is going to be that point. Okay. The other thing I can find, I kind of forgot, that's one of the simpler things to do, is to determine whether this opens up or down. I should point that out as well. This opens, according to my formula here, it opens down because the a value is negative. Okay. Because a is less than 0. Okay. Now, we should look at the domain and the range. The domain, as always, on a quadratic function is all real numbers. The parabolas extend left and right indefinitely, either up or down. Oop, that way. And in this case, it would be down, so they're going down indefinitely. The range, well, when I say down indefinitely, but the domain determines left to right, but they're pointing in the downward direction. The range is determined by that downward trend in the graph. So because this opens down and comes up to a maximum at the vertex, which is 7, right? The highest this graph is going to get is 7. The range then would be from -infinity up to 7. Okay, so the opening down makes it a -infinity to start off. The max value of the vertex gives you your endpoint. Okay. Now the last thing, well, two more things. The last thing before I do the graph is to write out the vertex form, right? We can always convert these standard forms to vertex form and the vertex forms to standard form. So in order to convert this to the vertex form, which is a times x minus h squared plus k, I simply plug in the a, h, and k that I now know. A we know is -3, h is 1, and k is 7. So we just plug those three values in and we have our vertex form. So f of x is -3 times x minus h squared. Oh, not h, h was 1, so x minus 1 squared plus the k value of 7. Okay, so this would be the equivalent vertex form of this standard form. And in fact, if you were to expand this back out, write it out, x minus 1 times x minus 1, distribute in your -3, and then add your 7, you will get the original standard form up here. Okay. Now we should plot the graph. All this information is useful, but I am going to jot down the information, or all these points here. So just to summarize, so 0, 4, because I need some space, I'm going to erase some of this stuff. So 0, 4 is my y-intercept. My x-intercepts are 2.53, 0, and -0.53, 0. The point symmetric to the y-intercept is 2, 4. Axis of symmetry, x equals 1. And the vertex is at 1, 7. Okay, so all that stuff is important. I will get rid of, oops, well, I guess I'll get rid of the function too. Give myself some space to plot this graph. If I look at all these values, I definitely need to go up to 7 in the y direction. My x direction really doesn't get beyond like 3 and -1, so I don't really need too much in the y direction, or in the x direction. And the y's never really get on this one. Well, the y's go from 7 down, I guess, if I look at the range there. So I do need some. Oops, that wasn't very straight. Hang on. Okay, good enough. Okay, so let's go up to 8 maybe in the x direction, or in the y direction. That'll make sure that I get the 7 in there. Okay, and then let's see, left to right, let's go up just to 4 maybe, that would be sufficient. So there's 4, there's 2, 3, 1. And then we'll try to keep the distance the same. 1, 2, 3, and 4. And then vertically, let's go down a few more. Maybe down to 4. Okay. So when I plot these, 0, 4 is my y-intercept. 2.53 is right about there. -0.53 is right about here. 2, 4, that's my symmetric point. I go up 2 and over 4. Okay, I'll erase those little markings. My axis of symmetry is at 1. Should cut right between those symmetric points. And of course I didn't draw that very straight. And then 1, 7 is my vertex. Alright, so you can see 5 points, 2 X-intercepts, a Y-intercept and its symmetric point, and the vertex are in there, that's 5 points. And my axis of symmetry is in there. Again, there are times when the graph will not have X-intercepts. If this was opening down but had a maximum that was negative, you would not hit the x-axis, and so we'd only have 3 points to plot, and that's okay. But it's nice if we can get all 5 to do so. And from here I want to curve this around. Run that out a little far. That's better. And this is quite a narrow graph based upon what I have plotted here. I do want to make sure that I round this off. A parabola is never comes to a point. It actually has a rounded maximum or minimum. The vertex is a rounded point, not a corner. Okay, so that's important too. And then these arrows go on indefinitely downward. And you can see the domain and the range match up. The domain is all real numbers because these arrows, though they point down, also point left to right indefinitely. And the range starts at negative infinity and works its way up to 7 as a maximum. Okay, so that should give you an idea of how to find all these little details, all these pieces of information and features of the graph of a parabola based upon the standard form that was given originally.